lowest point right here. And let's say I have the pendulum bob, which they have a little circle at the bottom there. And something like that. And you raise it. They give us the height above the ground, which that's nice of them and all. So it looks something like this. We're led to believe now that the object is, been lifted 0.08 meters above the ground, or above its lowest position. Can you, from that information, figure out what theta is? We know this string length is 1.5 meters. And this is definitely a math question. It's not particularly hard, but my experience with students is that they have a difficult time doing this. That's been my experience. So I'm not saying this is on the quiz tomorrow. I would like you to be able to do it. By the way, that's really the issue. Is we've talked about this in class. This is not actually something that's new, and there's a formula that you could use, but there's some trig here, and it's not particularly hard trig. If we just draw that dotted line, that may or may not clue you into what you have to do. But this is h, and all of this is L. This right here, and I'm kind of drawing all over this, making a mess of it all. This is the adjacent side of a triangle. And this would be the hypotenuse of that triangle. So cosine of theta would be A over H, which means the adjacent side would be H, not H. I don't want to use H there. Let's use L. The length of the string is the hypotenuse. There. Anyways, the adjacent side is A, but I'm noticing that the height has to be L minus the adjacent side, which means the height has to be L minus L cosine theta. This is how you could figure out what theta is. Now I have two questions, so what's that? You can't see what I'm drawing? I never switched it back. So you're just looking at a screen there, and I've been drawing this whole time? So is that what Ramya and Paige are both asking too? All right, I just want you all to know something, and I hate to be the person to do this. I'm going to lower your hands for a minute. If you did have an actual question, Ramya, what's your question? I just lowered your hand. Is it different than what this is? Okay. Well, I'm going to switch over now. I appreciate you bringing that up, because that probably makes a heck of a difference. But I've been doing stuff like this all day long today. Starting with totally missing my first class today because of an issue at my house with power. And then continuing the third period, where I made nothing but the same mistake over and over and over and over again. So much so that the whole class has pronounced that April 8th is Mr. Shelton Makes Mistakes Day. And fourth period, let's just say I didn't hit record at any of the right times. So this whole drawing now looks like a complete mess to all of you. In fact, if you're trying to write it down right now, then you should probably just stop, because it's a garbled mess. So since there will be no re-recording of this, everything I just said I'm just going to say over again, but perhaps nicer. So you guys watching it, are watching this live, keep in mind the length of the string. I'm just overlapping it right now, but I'm not going to leave those blue lines there. That's what I'm going to call L. So that's the length of the string. If I draw this dotted line here, this length, which is in yellow, I'm going to call A, because A and L together form the group that would be responsible for the cosine of the angle. Right? A is the adjacent side and L is the hypotenuse. Is that okay? Well, this distance is the height. The object is lifted due to being pulled upwards that angle theta. In the problem, it's 0.08. But here, A plus H has to equal the length of the string. So, if I do a little substitution, I'll get L cosine theta plus H equals L. So that's what you need. First, this is a way to get the angle if you have H. This is also a way to get H if you have the angle. It's not on the equation sheet or anything, but it could probably come in handy. You can see how it would come in handy, I hope. Also, interestingly enough, and I do want you to kind of see this. Yes? Let's see, Skylar, you have a question? I believe so. The problem or getting the angle? Oh, I don't think this has anything to do with the problem. No, I'm using this as a teachable moment. And I'm saying this because them giving you the angle might make it hard for some of you to figure out how much energy there is. They gave you the height on purpose because it makes it really easy to do. But they don't have to be so generous. Does that make sense? For a pendulum, the angle represents the amplitude. So they could provide you the angle instead, which I think would be a tripping point for a lot of you. I do want to point out something like, so this teachable moment. The gravitational potential energy for any object is mgh. From here, the gravitational potential energy then would be mgl times 1 minus cosine theta. Now, I know that looks weird, but just stay with me for a minute. Theta is constantly changing for a pendulum, right? We know that theta is oscillating. So this would show you that your gravitational potential energy would also oscillate. But it'd be weird because theta is like theta max cosine square root of L over G times T. I'm sorry, square root of G over L times T. Remember all that? That would mean you'd have to put this in for theta here. So it'd be the cosine of the cosine. It's weird, isn't it? That's not cosine squared, by the way. But it would give you a weird oscillating gravitational potential energy. Anyways, teachable moment, not a huge deal, not related to the problem. So let's get back to the problem because that's what you guys came here for. So there. I expunged it from our memory so you won't have to think about it. So the problem asks several things about this, but it says first, on the figures below, draw the free body diagram showing and labeling the forces acting on a bob in each of the situations described. Hope that wasn't too tough, but let's just handle that real quick. When it's down here, just two forces, tension, which is going to be much greater than mg if it's moving. We know that because there has to be an unbalanced force upwards. So if you were doing this in my class for a test, you better show the tension being greater than the weight. And then here, tension should also be greater than the weight, but in this case, the tension would still lie along the string. Any questions about that? Okay, so moving on. It says calculate the speed u of the bob at its lowest position. So for this one, we're talking conservation of energy. It has mgh when it's at the highest point and 1/2 mv squared when it's at the lowest point. We can still use conservation of mechanical energy for this. So we'll have 10 times 0.08 equals 1/2 v squared. So v is going to be the square root of 2 times 10 times 0.08. I don't know what that is. So let's see, 2 times 10 is 20 times 0.08. It's going to be oh, I don't know, square root of 1.6? I don't have my calculator. But I think you guys can do that part. So I'm going to just go on. C says calculate the tension in the string when the bob is passing through its lowest position. Yeah, if I was going to ask a question on the exam, I'd love to ask this question. Probably won't be on the exam because the exam's not going to be super heavy in calculation, I don't think. But understanding why the tension is greater at the bottom, I think, is incredibly important. So I want to remind you that net force has to equal MAC. There has to be an unbalanced force in order for the object to travel in circular motion. And I think this is something that they will hit on the exam. If I choose up to be positive, which I think is a good point, I'll have tension minus mg equals mv squared over L for the length of the string. Because the radius of curvature for this object will be the length of the string. Now you just found V, so you can pop those numbers in there and get the actual answer for tension. I don't think that's necessary. I don't think getting the numbers is important here. I mean, it's important to you guys, sure, but I want to remind you that I think that the important detail here is that the object has to experience an unbalanced force. So for a pendulum, we can combine a lot of different problems into one problem with the pendulum here. In fact, I'd argue that we really haven't gotten the simple harmonic motion question yet. And question D is the only one that looks like a simple harmonic motion question, which asks, describe one modification that could be made to double the period of oscillation. And it says, describe one modification. There is only one modification that can be made. The thing about a pendulum that's different than a spring mass system is that the period of a pendulum is equal to 2 pi times the square root of L over G. Well, it's not easy to modify gravity. So in fact, it's like impossible. So it's not like you can say, well, I'm just going to change gravity to make it swing slower, which means the only modification can be to L. Now look, they want to double the period. So if you want to figure out what has to happen to L, you might want to realize that answer, that numerical answer, that's testable. And we've talked about how to do this. If you don't remember, solve for the variable that you're trying to figure out, in this case L. So I'm going to take t and divide by 2 pi, square it, and multiply by g, and that's going to equal L. And then recognize they are doubling the period. So wherever you see the period in there, put in twice the value. For us, that means 2t over 2 pi squared times g. Now, pull out the part of this that was there before. So I'm going to separate the 2 and get 4 all times t squared over 2 pi times g. And then recognize that this all equaled L. So 4 times t squared over 2 pi times g will equal 4 times L. So if you want to double the period, you need to make the string 4 times longer. So it says describe one modification to double the period. This is the only modification. And there's not like saying making the string longer doesn't really answer the question. I think you need to go the extra mile and say you have to make the string 4 times longer. And this kind of thing is definitely going to be on our exam. This is the kind of thing they like, for you to be able to see the relationship that exists between the numbers. All right, Rad Rudy, that's what you wanted to see, so I hope that was helpful. Is there anybody else who has a question on the homework?